Welcome back to another video on the Maths channel. It's your teacher Ms. Lim here, and in this video we're going to be looking at future value, depreciation, and credit cards. So by the end of this lesson you'll be able to understand the concept of future value and present value, as well as solve problems involving future value, depreciation, and credit cards. This video will be related to the Year 12 Standard 2 course. So let's have a look at this lesson. Present value is just how much something is worth right now, hence the word present, whereas future value is how much something is worth in the future, hence the word future. Now, if we think about it, the future value of something could either go up, down, or stay the same. It can go up if it appreciates in value, so it goes up in value because of inflation, or it could go up because of interest. You could make an investment and you get interest from the bank, and so your investment will grow. Or you could borrow money from the bank, but you're being charged interest, and therefore your future value will grow, as in you will owe more money. Now, interest can be calculated in two ways: simple interest and compound interest. These are the formulas for them. Simple interest I equals PRN. So the simple interest earned is equal to the principal times the rate times the number of periods. This formula is not on your formula sheet. Compound interest, the formula is A is equal to P times 1 plus R to the N, or the end amount, is equal to the principal times 1 plus the rate to the power of N, the number of periods. Or instead of writing that, because this is what we learned in, I think, year 9, we're just going to replace A with FV, future value, and principal with present value. So the future value is equal to the present value, how much we invest right now, times 1 plus the rate to the power of N. Everything's exactly the same, we just changed the letters. This formula is on your formula sheet. So here's our formula sheet. Future value is equal to present value times 1 plus R to the power of N. Also on our formula sheet for this topic is the salvage value is equal to the value at time 0 minus depreciation per year times number of years, as well as the declining balance method of depreciation. Salvage value is equal to value at time 0 times 1 minus R to the power of N. So we have them here in our lesson. Straight line depreciation, if a question were to ask you that in HSC, it will specify straight line depreciation. Or it might say a dollar amount per year or per time period. Okay, it could be per month. Whereas a declining balance method of depreciation means it doesn't go down by the same amount each time, but by the same percentage. So a question might say it depreciates by 23% per annum. Okay, so it's going down in value. That's why it's a minus. And because it's got a percentage, we know we need to be using this formula and not straight line. So this is, use this for percentage. So you'll notice that these two, this is very similar to this. Okay, we're just using different letters, and instead of plus, it's a minus because it's going down in value. But make sure you know how to use each of these formulas. So S stands for salvage value, which technically means future value. It's just gone down. V0 means value at time 0. So you could have bought a car brand new at $70,000, so V0 will be $70,000. Or you could have bought a car second hand for $23,000. V0 will be $23,000 because that's how much you bought it for at the very beginning, at time 0, not necessarily when it's brand new. Okay, now it's important also for you to know that whenever we're using these formulas like compound interest, future value, and a declining balance method of depreciation, that the rate and the number of periods must be in the same units. So if the rate is per month, then we need the number of months. If the rate is per annum, then we need number of years. If the rate is per quarter, then we need number of quarters. Okay, same with this. Must be the same units. Alright, so let's have a look at the second part of this lesson, which is solving future value, depreciation, and credit card problems. Example A. $1,000 is invested at 5% per annum simple interest. What is the future value of the amount in 3 years? Now this says simple interest, so I need to use that simple interest formula. I is equal to PRN. Well, $1,000 is the amount invested, that's the principal. The rate is 5% per annum. And the number of years is 3. So when we put this in our calculator, we get 150. But just know that this is $150 worth of simple interest. This is the interest. The question is asking what's the future value of the amount. So how much will be in the bank technically? Future value will be the $1,000 we put in plus the $150 of interest we received. So altogether $1,150. Question B. $1,000 is invested at 5% per annum compounded annually. What is the future value of the amount in 3 years' time? Sorry, let me just get rid of that. In 3 years. So future value is equal to present value times 1 plus r to the n. Future value, this $1,000 is the amount invested. That's our present value. That's how much we have right now. It's invested at 5% per annum, compounded annually, so I don't need to divide that percentage by anything. And n is 3. Okay, so we can see here 5% per annum compounded annually, 3 years. Annually and years, they're the same units. So I'm just going to put this into my calculator. And I get 1157.63. Okay, and that's the future value. Alright, question C. $800 is invested at 3% per annum compounded annually. How much is in the bank account after 5 months? So we'll just write down the formula again, just so that we can get used to it. Future value is equal to present value times 1 plus r to the n. $800 is invested, that's my present value. The rate is 3%, and it's compounded annually, so I'm not going to divide it by anything. And it's invested for 5 months. Now you might be tempted to write to the power of 5 here. But if you do that, you're telling me it's 5 years. Because here we've got annually, and here we've got months. They are in different units. So what I need to do, because I didn't divide my percentage by anything, okay, I'm keeping it per annum, per year, I need to work out how many years there are in 5 months. All I need to do is just divide that by 12. And now I've converted 5 months into years. So I'll just type that into my calculator. And that gives me $809.91. Okay, so after 5 months, your $800 investment has grown to $809.91. If the question asked you how much interest was earned, we just need to subtract 800 from that answer. Question D. What is the future value of $25,000? What is the future value if $25,000 is invested at 2.85% per annum, compounded monthly for 17 years? So formula, future value is equal to present value times 1 plus r to the power of n. $25,000 is invested, that's my present value. The rate is 2.85%. But it's compounded monthly, so I need to divide that by 12 because there are 12 months in a year. For 17 years. But because I divided by 12, I need to times that by 12 so that they are now in the same unit. Remember, this is per month. So we need to work out how many months are there in 17 years. Just times it by 12. So 25,000. 1 plus 2.85%. Don't forget to write your percent symbol in your calculator. Over 12 to the power of 17 times 12, which is $40,560.77. Okay, and that's the future value. Alright, question E. How much interest was earned if $1,850 is invested at 4.7% per annum, compounded quarterly for 9 years? So future value, present value times 1 plus r to the n. $1,850 is invested. %, compounded quarterly, so we need to divide that by 4. To the power of 9. Now, these are not the same units. Okay, this is per quarter, this is 9 years. So I need to times that 9 by 4. So a quick tip, if they are not in the same units, whatever we divide the percentage by, we need to times the years by. Okay, we won't always be doing that, especially for credit cards, because they will usually already be in the same unit. Okay, I'll go through an example of that later. So 1850, 1 plus 4.7% over 4 to the power of 9 times 4, which is $2,817.13. That's the future value, but make sure we answer the question. The question says how much interest was earned. So therefore, interest earned is future value minus the present value. 2,817.13 minus how much we invested, 1850. So the interest earned is $967.13. Okay, question F. How much interest was earned if $7,584 is invested at 6.1% per annum, compounded monthly for 11 months? So compound interest, so we need to use the future value formula. This is invested, so that's our present value. The rate is 6.1% compounded monthly, so 6.1% divided by 12. Now this says for 11 months. So they are technically the same units, compounded monthly and for 11 months. So I don't need to times that 11 by anything. $7,584, 1 plus 6.1%. Oops, percent divided by 12 to the power of 11. $8,019.02. Again, the question says how much interest was earned, not what's the future value. So therefore, interest earned, which is future value minus present value. 8019.02 minus 7584. $435.02. Right, question G. What is the price of a $550 washing machine after 3 years of inflation if the inflation rate is 2.7% per annum? So inflation means it's going up in value. So a $550 washing machine right now is going to cost more in the future. Okay, so that's technically what inflation means. So because we've got an interest percentage rate, we're going to use the future value formula. It costs $550 now. The rate is 2.7% per annum, so we don't need to divide it by anything because it's not compounded daily or monthly or quarterly. And that's for 3 years. Okay, so per annum, 3 years, same units, so we don't need to divide or multiply by anything. So $550 times 1 plus 2.7% to the power of 3. $595.76. Okay, so that means if you were to buy a washing machine in 3 years' time instead of right now, you're going to have to pay $45.76 more. Question H. A $1,600 laptop depreciates at a rate of $320 per year. How much is it worth after 4 years? So here we're using depreciation and it's telling us it's going down by that much per year. So when we look at our formula sheet, we are going to be looking at this formula, not the other one, because it's an amount per year, not a percentage per year. Okay, so according to this formula, the salvage value or future value is equal to the value at time 0 minus how much it depreciates by per period times the number of periods. So S is equal to V0 minus dn. We want to work out how much it's worth after 4 years. So V0 is the value at time 0, $1,600. It depreciates by $320 per year for 4 years. So that was 1,600 minus 320 times 4. Oh, $320. So after 4 years, it's worth $320. Right, part I. A $1,600 laptop depreciates at a rate of 25% per annum. What is its salvage value after 4 years? So because it's depreciation and we're given a percentage, we need to use this. Okay, because ask for a percentage. So the formula is S is equal to V0 times 1 minus R to the power of N. Okay, remember depreciation is minus, so it needs to go down in value. So V0 is 1,600. The rate is 25% per annum for 4 years. Per annum, years, same units, so don't need to multiply or divide by anything. And we can just punch these numbers into the calculator and see what we get. $506.25. That is the salvage value. That's how much it's worth after 4 years. Right, question J. A $72,000 car depreciates at a rate of 18% per annum. What value did the car lose after 10 years of ownership? Depreciation, a percentage. I know I need to use this formula, V0 times 1 minus R to the power of N. So 72,000 is V0. The rate is 18% to the power of 10. 72,000 1 minus 18% to the power of 10 is 9896.26. Now the question asks, what value did the car lose? Not how much it's worth. So now we know after 10 years it's worth $9,896. But how much did it lose? Value lost is the value at time 0 minus the salvage value, which is 72,000 minus the 9896.26, which is $62,103.74. Right, question K. $180 worth of clothes were purchased with a credit card with a compound interest rate of 18% per annum and no interest-free period. What is the total amount paid for the clothing if the credit card account was paid 14 days later? So the thing with credit cards we need to remember is that it's always compound interest. Okay, so we're going to use the future value formula. So we bought $180 worth of clothes. The credit card has an interest rate of 18% per annum. But that's it, 18% per annum. It doesn't say it's compounded daily. Okay, so I'm just going to write 18% per annum. And we want it for 14 days. So this is per annum, or per year, so we need to work out how many years is 14 days, or just 14 out of 365. So 180, 1 plus 18% to the power of 14 over 365. That's going to give us $181.15. Okay, and that's the total amount paid for the clothing if it was paid on 14 days later. Now the working out will be different if the question said that it's 18% per annum compounded daily, because then we have to divide this by 365. So maybe I'll just show you that over here. If the question said 18% per annum compounded daily, then this is the working out. Future value is equal to 180 times 1 plus 18% divided by 365. Now that's percent per day for 14 days. And that's it. Okay, because now they're the same units. If we were to put that in the calculator, what do we get? 180 bracket 1 plus 18% over 365 to the power of 14. We get $181.25. Can you see how it's a little bit different? Okay, so make sure you understand what the question is actually asking. This one does not say that it's compounded daily, even though most of the time it is. So just be careful with what you do. Alright, question L. An $800 phone is purchased on a credit card with a 45-day interest-free period and a daily interest of 0.05% compound interest. So this is daily interest. It's already telling us per day. What amount of interest is charged if the amount is paid on the 75th day? So future value is equal to present value times 1 plus r to the power of n. We bought an $800 phone. Daily interest is 0.05%. Don't forget the percent symbol. But for how many days? Well, there's 45 days worth of interest-free period. Okay, so we're not being charged interest for 45 days. we're only going to be charged interest from every day afterwards. So if we're paying on the 75th day, we're only paying interest for 30 days. So you have 800 times 1 plus 0.05% to the power of 30. Okay, because this is per day, 0.05% per day for 30 days, they're in the same units. That gives us $812.09. That's the future value. That's how much we're paying on the 75th day. The question is asking how much interest is charged. Interest charged is the future value minus present value. 812.09 minus $800, which is $12.09. Alright, this is the last question here, but I might want to add a couple more questions after this one, because I realized that I didn't ask how to calculate present value or an interest rate. So I'll quickly create some questions after this one. Emily has a debit of $6,000 on a credit card with an interest rate of 12% per annum compounded daily. She decided to transfer the balance to a new card with a 0% balance transfer for 6 months. How much does she save in the first 12 months if the new credit card has an interest rate of 18% per annum compounded daily? So I might just highlight some information here. $6,000, 12% per annum compounded daily. Okay, I'll highlight that in yellow because they are all related to the same credit card. And I'll highlight this new card in orange, 0% for 6 months, and an 18% per annum compounded daily. So, if she were to keep her old credit card, let's just go, old credit card. Future value is equal to present value times 1 plus r to the power of n. She owes $6,000. The rate is 12% per annum compounded daily. So we need to divide that by 365. And we want to know how much does she save in the first 12 months. So that's technically 365 days. Okay, so if she had $6,000 on her credit card and didn't pay it off until the very end of the year, how much would she have owed? 1 plus 12% divided by 365 to the power of 365. She would have owed $6,764.85. But with a new credit card, future value is equal to present value times 1 plus r to the n. She was owed $6,000. She owes $6,000 times 1 plus the new rate, which is only 18%. But that's compounded daily, so we have to divide that by 365. But she only needs to pay interest for 6 months, or for half a year, because the first 6 months is interest free, 0%. So how are we going to convert that? I'm just going to write 365 days divided by 2 to show that it's for half a year. And I'm doing that because I need it to be in the same units. I've converted this percentage into percent per day. So I need this into how many days are there in half a year. So just 365 divided by 2. Okay, don't do 2 to the power of half because that's just, I know that's half a year, but that's different units. That's years and this is days. Okay, so make sure they're in the same units. So with the new credit card, she would owe 1 plus 18% over 365 to the power of 365 over 2. 6564.90. Okay, which is less than her old credit card. So it's in Emily's best interest to transfer the balance to the new card. Now we need to answer the question. The question is asking how much does she save. Therefore, she saves 6764.85 minus 6564.9. Which is $199.95. Alright, I'm going to quickly type up 2 new questions and then we can go through them. Okay, question N. How much does Godfrey need to save in order to have $47,000 in 4.5 years' time if his bank gives him interest at 3.4% per annum compounded quarterly? So we've got future value is equal to present value times 1 plus r to the power of n. He wants to have $47,000 in 4.5 years' time, so that's the future value, $47,000. We want to work out what the present value is. That's why the question is asking how much does he need to save now. So that's what we want to work out. 1 plus the rate is 3.4% per annum compounded quarterly, so we need to divide that by 4. In 4.5 years' time, 4.5, and we're going to times that by 4, because this is in years and this is in quarters, so we need to work out how many quarters there are in 4.5 years. So we times it by 4. So if we want to work out the present value, we just use our algebraic skills and just divide both sides by all of this. 1 plus 3.4% over 4 to the power of 4.5 times 4. And let's see what we get. $40,358.18. So if Godfrey invests that amount right now, in 4.5 years' time, he'll have $47,000. Alright, last question. Michelle wants a $4,210 investment to grow to $10,000 in 18 years' time. What annual interest rate does she need in order to achieve this, if interest is compounded annually? So future value is equal to present value times 1 plus r to the power of n. We want it to grow to $10,000, so that's our future value. She currently has $4,210. We want to work out what the interest rate is, and the number of periods is 18. So the first thing we need to do is we need to divide both sides by 4,210. So we've got 10,000 divided by 4,210. So 1,000 over 421 is equal to 1 plus r to the power of 18. The next thing we need to do to get r by itself is to take the 18th root of both sides. So if I were to do the 18th root of 1,000 over 421, we will get 1 plus r. And then to get the rate by itself, we need to subtract 1. So the rate, the annual interest rate, will be the 18th root of 1,000 over 421 minus 1. So the 18th root of 1,000 over 421 minus 1. So that should be 421. And that's going to give us 0.049. Now to convert that to a percentage, we just times it by 100, which is equal to 4.9, I'll just write 2 here, 4.92% per annum to 2dp. Okay, I know this was a long video, but I hope you found it helpful. You should now understand the difference between future value and present value and be able to solve problems involving future value, depreciation, and credit cards. If you enjoyed this video and you would like to get more content, please give this video a like and subscribe. Have a fantastic day, and I'll see you in the next video. See ya.